How old were you when you got interested in astronomy?
I was very young when I first heard about astronomy. I turned away from it until I was at the very end of high school. And then I really, really got interested again. So I kind of decided I wanted to be an astronomer when I was about 17.
What got you interested in astronomy?
Well, I was always really interested in science, and I was always sort of good at science and good at math and stuff. And I was interested in biology and chemistry mostly when I was in high school. And I was kind of an overachiever, and I did all these biology and science, like other chemistry projects and stuff when I was in school. And I got kind of bored of it for my last year, and I decided to do something different. So a friend of mine happened to know somebody who worked in actually solar physics, and I got to meet with her. She was at a university, and I got to meet with her. And I asked her if there was an interesting school project I could do, and she basically handed me this book about comets. And I didn't know anything about them, but it was about how comets might have brought water to the Earth and helped to make the Earth what it is today via the water from the comets, which was a fairly new thing, a hypothesis back then. So I concocted this little experiment with like a fake comet and a hairdryer and like what would happen in Earth's entry. And it was all very silly, but I loved it, and I loved learning about it. And then I took some astronomy classes, and I just realized this is so amazing because you get to ask these really big questions, but it's all, in the end, it's all just physics. So you can learn the same physics of gravity and so forth that you learn here. And I love being able to do both of those things.
Are you interested in amateur astronomy?
Well, I am, but I don't have that much experience with it. When I was a kid, I lived in a big city, and there weren't really, I mean, there probably were astronomy clubs, but I didn't really know about them myself. So I got a telescope when I was actually about the same time I was really getting interested in astronomy, but then I went off to college. And so I didn't take it with me because it was a really big piece of kit, you know. And I left it behind for my brother, and so he used it a little bit. But I haven't got way deep into it like some of my friends are. I should say, a lot of professional astronomers know absolutely zero about amateur astronomy. It's a weird thing. They spend most of their time on computers. But some of them know a huge amount, and I'm kind of in between. Like, I know a little, but not. I mean, I think a lot of people who are proper amateur astronomers know much more about the practicalities of observing with a refractor, say, than I do.
What kind was the one that you had when you were younger? Like, what type of scope was it?
It was just a refractor, and it was, it was probably a 3-inch, if that. I don't think it was much. But it was enough that, I could see the basics. And the first thing I saw was the Orion Nebula, which I just went to myself. I managed to find it without much trouble, which was lucky. And then my first thought was, that is stunningly beautiful. That was my first thought. And my second thought was, but it's in black and white, because I didn't quite understand how hard it is to see color through a scope with the naked eye. So that was my first time with it. And yeah, I wish I used it more, really, but even now the skies are pretty bright where I am, so we don't get much done unless I go specifically to a group.
Where did you go to school for university?
I went to Princeton, which is in New Jersey, and I'm from California. I was just being a teenager, like, gotta go somewhere else. So I knew I wanted to do astrophysics, so I looked up where the best places to do astrophysics were. And there was one on the West Coast and one on the East Coast, and I was like, well, I don't want to be on the West Coast. I'm already there. So I applied to Princeton, and luckily I got in. It's really hard to get in, so I was really fortunate. There's lots of different universities, right? And it turned out to be a good fit, but the astro department there is great, but lots of other places are good too.
What is your specialty?
I study galaxies. And in particular, I tend to study galaxies at a range of distances that cover about a little more than half of the total age of the universe. So I look back at galaxies as they looked up to 9 billion years ago, which is quite a bit more than half, and then up to galaxies today. And so I look at the evolution of those over that time period. And particularly, I'm interested in the evolution of the structures of the stars and the shapes, the morphologies, so the configurations of the stars and how that relates to the supermassive black holes that live at the centers of galaxies. Because we know that they're related in some way, that supermassive black holes and galaxies grow together over cosmic time, but we don't really understand why exactly that should be. So I use those two things together. I study those, which requires me to study multiple different wavelengths to look at different parts of the black hole and parts of the galaxy.
How did you get involved in Galaxy Zoo?
Actually, my first interaction with Galaxy Zoo was just as a volunteer. I was in my PhD, and I check in the morning and read the news and see this thing and this article. It was, I think, on the BBC, and I just went, "That's the best idea ever." Where it just said, we need the public's help to look at galaxies. Because I was facing a similar problem in my research. I didn't have that many galaxies, but I had enough that I was thinking it would be great if we could have some nice way of making like quantitative measurements of the shapes of galaxies that's better than what the computers can do, because the computers aren't that great, but it's really, really easy for the human eye and the human brain to do. The computers try to decide what's even worth showing to people. So the computers can be pretty good at finding things like a star and telling the star apart from a galaxy and so forth. But even then, they sometimes get it wrong. So you show up, there are areas of the sky where the telescope, which is a dedicated telescope in New Mexico, is the Sloan Digital Sky Survey, that we use their data. And there's parts of it that the volunteers call the cosmic scarf, because it observes in these long stripes. And at the very ends of the stripe, sometimes the calibration goes way wrong and it gets these crazy colors. And it looks, if you zoom way out, it looks like a scarf in the fringes. Anyway, and the computers are terrible. And sometimes it thinks something is a star when actually there's plenty of galaxy stuff there. And then other times it doesn't. It thinks that there's a beautiful galaxy and it's really just a like massive green nothingness, as you see.
What do you do at Galaxy Zoo?
I'm primarily a Galaxy Zoo scientist. There are lots and lots of people involved in Galaxy Zoo. Many of us are scientists. Many of the team are developers who keep the site running and so forth. And I mostly do the research, and I also interact with the community. There's a pretty active community on a thing that we call Talk. That's basically where we can discuss the galaxies and discuss the science and discuss particular ones and groups and things. So I post on there and just sort of look out and watch the discussion and see what people are doing. People tend to do really cool science just on their own, even without my help. Other than that, I'm working on some of the data from the Hubble Space Telescope and getting those classifications that we've collected out to the public so that everybody can do science with them, not just us.
Why is it important for amateur astronomers to get involved in Galaxy Zoo?
Amateur astronomers have a lot to contribute to Galaxy Zoo because they know what these things look like better than most members of the public, if that makes sense. I love going to talk to the amateur societies because I can put up, we have these images of the discoveries that have been made, and I can put up something and say that green is oxygen-3, and people in the room actually know what that is. Versus if I go talk to someone else, and then I have to explain what that is and all atomic transitions and all of that stuff. And so there's an expertise that's really useful. But I think some of the most interesting things that we've been collaborating with amateurs is the kind of scopes that amateurs use, that is to say, generally refractors, are actually still best for getting really low surface brightness features in galaxies. And one of the things we've been working on in Galaxy Zoo is identifying these specific kinds of galaxies that we think have never had any significant galaxy collision, but they've only had kind of like where a little galaxy comes in and orbits and then eventually gets sort of eaten by the bigger galaxy. And those don't wreck the shape of the galaxy in the way that other things do. But one of the things that we've been doing specifically with amateur astronomers is a collaboration where we're investigating this type of galaxy that we've found the largest sample of so far that we think has never had any significant merger or collision, that's grown via sort of smaller events. And what that means is that it leaves a particular signature on the galaxies, because really large collisions and mergers, they tend to kind of destroy lots of structure in the galaxy, and they destroy evidence of past events. So if a galaxy has only grown through the smooth stuff and hasn't had a big merger, then all of those remnants are left behind for billions of years. And if we can observe to faint enough limits, then we can see them. And the kind of equipment that amateur astronomers use is actually ideal for this. And so we've been talking with several who will go out and collect data for us and, capture it, send it to us, and then we're combining them all together to build up a really deep image of certain galaxies, because we can use them to study the kind of fossilized remnants of galaxy evolution. It's a kind of galactic archaeology.
How many people classify each image, give or take?
Initially, when we started, I think we were aiming for something like 10, but it was so popular that we got something closer to 100 people classifying each image on the original Galaxy Zoo. And that's hugely valuable because it means that we get a distribution of votes. And so we know that, if everybody agrees, we're certain of the classification. And if the agreement is much worse, and there's lots of varying opinions, then we know that galaxy might just intrinsically be less classifiable. And that's quantifying that in a statistical way that no one else can do. So right now, on the galaxies that we have up now, we show between 40 and 80 people in general the same image of a galaxy, because we ask more detailed questions. So if there's a lot to see, then we ask more people so that we get that kind of vote distribution for all the different ways that they can answer. So it means that everybody should just go on and give their best guess, because no one person is going to either make or break the classification, because everybody contributes.
Yeah, and so if there's like a bunch of people who gave different answers, you can also get a majority, because there can also be people who like accidentally click the wrong thing, then they click down, it's like, oh no.
Oh yeah, that definitely happens. And there's definitely people who, we call them galaxy tourists, who just click star artifact on everything because that's the quickest way to get to the next galaxy, because all they want to do is just see the galaxies. So they just click everything's an artifact, even though it's not. And we have various ways when we analyze the classifications that we can identify people who just disagree completely with the crowd. And then we downweight those people. They're very rare, like 1 or 2 people in the whole project. So most people are really trying to contribute and make a real contribution, and they do.
Yeah, because I've done like 3 or 4 where I'm like, wait, I didn't want to press that, it was something different. Or like after I do it, I'm like, oh wait, that was lens or arc drag.
Yeah.
I've done that one more than anything else, where it's a lens or arc, but I classify it as, I've done that with a merger and an irregular one, so I was like,
Oh, it's all right. Well, there are other projects where we've applied really interesting techniques, and you can see people learning and getting better as they go. It's really cool to watch, and it's really nice to be able to assess that.
How does Galaxy Zoo help your work?
Well, the work that I do, I couldn't do any other way, because the galaxies that I study, right, the ones that I talked about before, the ones that don't have any mergers, that they're still big galaxies, maybe like as big as the Milky Way, but they've just formed without any of these big mergers. The trace that they leave on the galaxy, or rather that they don't leave on the galaxy, they lack the central bulges that other spiral galaxies have that have been through mergers. And the lack of that trace is very hard for computers to identify, at least in a way that's really consistent and accurate. So I could ask a computer to do it for the whole survey, which is like 1 million galaxies, but the error rate would be really high, and they're really rare. So I might expect to only find a few hundred in the whole survey. And if the error rate is 20%, then there's a lot of galaxies I've got wrong, and that can ruin my sample. But by eye, it's really obvious, and people are extremely accurate. And so I can pick out the galaxies that I'm sure are a really clean sample of that, and then I can study them, and I look at their black holes.
Yeah, because with computers, right, they'd probably track a certain thing, and if that doesn't match it exactly, it doesn't.
Exactly right. And if there's anything like the satellite trail or an artifact or anything in the image that's other than the galaxy, and it's unexpected, the computers have a really hard time with that, whereas people can just go, it's a satellite trail, and ignore it. But you can't program that yet. Part of what we're trying to do with Galaxy Zoo is help train machines to do this kind of galaxy classification better, so that we can then move on and get everybody involved on other problems, harder problems.
How many researchers use the data from classified galaxies?
On the Galaxy Zoo team, there's maybe like half a dozen people who are like professor level, so faculty level. Next level down, another half a dozen or so, that's postdoc, that's me. And then there are lots of graduate students as well, and all of us are using it. So there have been Galaxy Zoo, PhD theses been written. So there's just in the Galaxy Zoo team more than a dozen people, scientists, and then within the larger, wider public, because we publish the classifications as a public catalog. We've had people who are volunteers who've gone into the classification and used them. That's a small subset because that's a lot of work. Most people are just doing this in their spare time. But we've probably had 2 or 3 times as many people as on the team who are outside of the team but are still using our classifications. So it's, dozens, probably less than 100, but it's a lot of scientists, a lot of people in galaxy evolution use Galaxy Zoo data.
What is Galaxy Zoo Talk?
Talk is the place where we have a community where at the end of a classification, you're asked, do you want to discuss this? And if you have any question at all about the classification you just put in, you can click yes, and it will take you to the community, and you can post a question about that particular galaxy. You can see what other people have said about that galaxy, including people who are moderators, scientists, so forth, people who are experts, who've been on, some of the moderators are better at classifying than I am. And then you can also go to, there's a larger community where you can just have a chat, or you can talk about science, or there's different people post in different languages, and that's always fun. And it's just the place where we work on problems together. And there have been some really interesting discoveries actually that have been made using the community, an earlier version of the community, but some really, really cool things we've found about. Actually, one of them was a black hole. There was a new kind of phase in the black hole's evolution that was discovered via the community. The discoveries are great. That discovery was a school teacher she's Dutch, and she came on and went, "What is this thingy? I don't know what this is." And it was this little smudge by a galaxy, and it turned out that little smudge is actually an ionized cloud of gas that's 50,000 light years away from the galaxy, and was being lit up by the remnants of when the black hole was active, but it wasn't active now. So it's like catching a light. It's like taking a photo of a room after you've turned off the light switch, but before the rest of the room knows it's dark. It's 50,000 light years, so there's a big room to cross, so it takes 50,000 years, right? So we've caught it in this particular phase. Anyway, and so she discovered that object, and that object had actually been on the, in astronomical data for 50 years. It's on these old photographic plates, but no astronomer ever either had the time or realized it was worth asking a question about. It just looks like a little smudge. And so it took a volunteer going, is this something? And then the scientists in the community going, that might be something, let's check. And then everybody coming together. And since then, one of the questions that was asked was, is this the only one that exists, or are there more in the data? And it turns out that there are many more. There are dozens more in the data. So it's a whole new class of objects that were discovered. But on a more day-to-day basis, what happens is that you get people who are new to the project, and they come and they ask questions, and then people who are more experienced answer the questions. And so the community teaches each other, which is a really, really valuable resource, actually.